Hi, this is Leo Kim.
And Andrew Krodinger.
Today we're going to be talking about defining a context-free grammar. And we're going to be talking about two main points. The first is going to be eliminating syntactic ambiguity that arises from recursion. And the second is going to be enforcing operator precedence.
So we learned in class how to formally define the JavaScript language using a context-free grammar annotated in BNF. But what we want to do is something similar for an English language, of course with limited expressivity.
Let us consider Englishy, an English-like language that allows us to express, well, a very small subset of actual spoken English. So in the slides to follow, we're going to give you some very informal specifications of what we want our Englishy grammar to look like. So we want our Englishy grammar to be able to unambiguously express the following sentence.
Jack and Jill eat puppies and kittens or ice cream and lollipops. For the purposes of our example, we want to set up some initial conditions for our terminals. We're going to set a conjunction to be and or. We're going to set a subject noun to be Jack or Jill. We're going to set our verbs to be kill or eat or lick. And we're going to set our object nouns to be puppies or kittens or ice cream or lollipops. We also wanted to informally declare some specifications for our grammar. We want to make sure that every sentence is a noun phrase followed by a verb phrase.
Now, that being said, what can our noun phrases and verb phrases look like? And again, I'm being very informal, but I want you guys to just kind of think about it at a high level. Well, one thing it could be is that it could be just one of the subject noun terminals. For example, Jack, Jill. Well, another thing we can have is that we can have it be some kind of permutation of Jack and Jill, or Jill and Jack and Jack and Jack and Jack and Jill, or Jack. That is, we want our terminals to come from the subject noun non-terminal with conjunctions in between. Now, that being said, what can our noun phrases and verb phrases look like? And again, I'm being very informal, but I want you guys to just kind of think about it at a high level. Well, one thing it could be is that it could be just one of the subject noun terminals. For example, Jack, Jill. Well, another thing we can have is that we can have it be some kind of permutation of Jack and Jill, or Jill and Jack and Jack and Jack and Jack and Jill, or Jack. That is, we want our terminals to come from the subject noun non-terminal with conjunctions in between. So at this point, we want you guys to think of our conjunctions kind of as binary operators in our JavaScript grammar. Now, I know it's kind of weird to think about it that way since we're talking about a natural language kind of like English, but remember, we're talking about Englishy, which is for which we are defining the grammar. Now, what can our verb phrases look like then? Well, one specification that we want to make is that it must have exactly one verb at the beginning. So our verb phrase can start with kill, eat, or lick. And then it can be followed by any combination of puppies and kittens and ice cream, or lollipops and puppies and kittens, or ice cream or puppies, or whatever. The important part to remember is that in between all these object noun terminals, we want to have one and exactly one conjunction. Now, given these still very informal rules, I think you guys will agree with us that we could certainly construct our reference sentence.
Jack and Jill eat puppies and kittens or ice cream and lollipops. So we want to try to formalize these rules and see what happens. So Leo, we wanted to start at the starting point, right?
Yeah, exactly. So guys, if you remember, a context-free grammar always has a starting point. And Andrew, in this case, our starting point is going to be, we're going to annotate it with S, and it can be what? Like we said before, it can be a noun phrase followed by a verb phrase, right?
Correct.
So what about a noun phrase?
A noun phrase should be either a subject noun or a noun phrase with a conjunction followed by a noun phrase.
Yeah, and because we have this recursive kind of thing going on where the noun phrase can be either well, actually not either, but both on the left and the right of our conjunction, which, again, guys, remember, we're trying to think of it as a binary operator here. That allows us to do that chaining we were talking about before, right? Like, for example, what? Like Jack and Jill, or Jill and Jack and whatever, right? And our verb phrase, we gave that informal specification earlier that it had to start with the verb, right? So what are our verbs again?
They're kill or eat or lick.
Right. And then after that, we can have what we're going to make another non-terminal called an object phrase. And those object phrases, it's going to look a lot more like our noun phrase above, right? So again, it kind of has that singleton thing, or that kind of recursive thing going on, with the conjunction being the binary operator and us being able to recurse both on the left and the right side.
Okay, so this is like our first step in BNF of trying to formalize the sentence Jack and Jill eat puppies and kittens or ice cream and lollipops.
Yes, so that's all well and good, but I kind of feel like we have a problem here, Andrew. So we talked about that whole idea of recursion, but the problem is, what if do you think with this grammar as it stands, we can have some kind of syntactic ambiguity?
Well, I think so, and I'm thinking I see two places. Is there two places that anybody else could see? If you said noun phrase or object phrase, you are correct.
Right. So where would that syntactic ambiguity come from? So guys, remember we talked about in class that, one easy way to tell if there is syntactic ambiguity is to think about, can we draw more than one parse tree for the same string, right? In our case, a string being, a sentence. Our reference sentence being Jack and Jill eat puppies and kittens or ice cream and lollipops. And the ambiguity arises from the fact that we can recurse both on the left side of the conjunction and the right side of the conjunction for both the NP non-terminal and the object phrase non-terminal.
So we want to enforce left recursion. How would we fix this?
So yeah, if we wanted to enforce recursion only on the left side, that would mean that in the NP rule, for example, that on the right side of the or of the meta language or, we would want it to look like NP conjunction followed by some other non-terminal that is not NP. Because if we had that NP on both sides of our binary operator, dot dot dot, or conjunction, we will call it, then if we had it on both sides, then it would recurse on both sides. But if we only had it on one side, it would only recurse down that one side. Same thing, of course, for the object phrase rule.
Ah, I think I see. So if we replace the NP in the noun phrase with maybe something like subject noun, then that would allow us to enforce a left recursion.
Exactly, because the subject noun, it's not a terminal in itself, but it's not calling NP again. It's only calling NP on the left side of the conjunction, which, again, we're trying to think of as our binary operator. Remember, guys, if you have a unary operator, the reason I keep bringing this up is because if you have a unary operator, like, for example, not in our JavaScript language, you can't actually enforce recursion on one side or the other because there is only one side, so to speak. And I guess, Andrew, like if we wanted to do the same thing for object phrase, how do we do that?
It looks like we just took our object noun and placed it there at the end. Again, forcing the same style of left recursion we did in the noun phrase.
So you're saying that if we had object phrase goes to some kind of thing that looks like object phrase, binary operator slash conjunction, followed by some other non-terminal that is not object phrase, then we're enforcing left recursion?
Correct.
All right, I can buy that. I can buy that. So at this point, I think we've pretty much eliminated the syntactic ambiguity that arises from allowing recursion on both sides, right? So let's look back at our reference sentence again. Jack and Jill eat puppies and kittens or ice cream and lollipops. I'm not sure what it is they're eating right here. Is it puppies and kittens or ice cream and lollipops? Like, are those two grouped together? Or are they eating puppies and kittens, or they're eating ice cream and also lollipops? I mean, I feel like there's some kind of ambiguity here.
Oh, so you're saying I should maybe enforce a type of binding on them or some type of thing to make them take a higher precedence?
Exactly. I mean, I think like if we're looking at it from a natural language perspective, right? If I were to just say the sentence to you, Jack and Jill eat puppies and kittens or ice cream and lollipops, I kind of feel like intuitively we would kind of group the puppies and kittens phrase together and the ice cream and lollipops phrase together, and we would kind of want to try and say something like this. Jack and Jill either eat puppies and kittens or they eat ice cream and lollipops. I mean, do you kind of feel like that's like kind of the natural way to say it in English?
I do, I agree. And let's try to enforce that in the rules. Okay, now let's try to enforce that in our Englishy grammar.
You know what? Yeah, let's try to do that. So, okay, if we're thinking about it at a high level, if we want an operator, and again, we've been talking over and over again about our conjunctions being what again?
Binary operators.
Yeah, binary operators. So in a binary operator, if we want to enforce precedence, we would want it to come at the top or the bottom of the parse tree.
The bottom.
The bottom. Yeah, so it's because we want it to come at the bottom of our parse tree. I guess that means that our and operator we would want to be a part of, or a constituent of, so to speak, our or operator. So how would we enforce that?
So, Leo, what's this thing we added to our terminals? I see that our noun phrase is now splitted from noun phrase by itself to NP or and NP and our object phrase is now the same.
Yeah, so let me talk about that for a second. And so what we did was we added a couple non-terminals, right? Can you point out the new non-terminals that we added? So now we're going to change, just to make it a little easier for you guys to read, what was before NP, we created a new non-terminal for it, and we call it NP or. So now our sentences can be an NP or followed by a VP. We also added a new non-terminal called NP and we changed our original object phrase to an object phrase or and added a new non-terminal object phrase and. And if you see the pattern that's going on here, is that we're still enforcing left recursion because if you look at NP or, you can see on the left side of the binary operator or the conjunction or, you can see that we recurse into NP or, and we can do that over and over again. But on the right side, we don't recurse, but we go to a new non-terminal NP and the NP and can now go to the non-terminal subject noun, or it can continue to recurse on the left side down into NP and, or on the right side of the binary operator or conjunction, if you will, and we can have a subject noun. And in this way, you can kind of see that because we make our NP and non-terminal a constituent of our NP or non-terminal, we're enforcing this kind of precedence. Now, Andrew, can you think of any possible way with this grammar as we have it now? And guys, of course, remember that looking at our object phrase or an object phrase and, it's basically following the same exact kind of idea as the NP or and NP and. Do you think we can possibly draw any kind of parse tree where the NP or is going to come below the NP and, keeping in mind that the NP and can only ever be a constituent of an NP or?
So yeah, Leo, so what you told me was NP or is left recursive and NP and is left recursive. And NP and is a constituent of NP or. So now I know that NP or could never come out of NP and once we're inside NP and. Therefore, NP or could never be lower than NP and in the parse tree.
Right. And NP and would always have to be lower than NP or in the parse tree. So, we talked about three different I guess like three different kind of phrases to express this idea. And one of them was what? Binding tighter?
Yes. Yeah, so what I've garnered from the way that Professor Chang talks is that we can talk about it as binding tighter, it having higher precedence, or it being lower in the parse tree.
Right. So in our case, you're saying that the and operator, which again, it's just a conjunction, but we're kind of thinking of it as at a high level as a binary operator. You're saying that the and operator is bound tighter, has higher precedence, and is lower in the parse tree.
That's correct, Leo.
You know what? I think that makes a lot of sense. So at this point, I feel like we've kind of accomplished the two objectives that we set out from the beginning, which were to eliminate syntactic ambiguity that arises from recursion, and we did that by only allowing recursion on the left side, and also by enforcing we enforce some kind of precedence for operators. And I think we did that too by allowing our higher precedence operators to only be constituents of our lower precedence operators.
So congratulations, you guys. You're the first ones to experience the Englishy language written by Leo and Andy.
So, okay, guys, I know it's a little bit silly that we're using Englishy to kind of express this idea of, okay, can we define a formal grammar using it? And of course, in a real natural language like English, it's a lot more complicated. But the idea is that the principles we learned in this class, they do matter, and they can be transferred to a more natural like language that we can define, such as Englishy. Now, I hope this was helpful for you guys, and I hope it helped kind of disambiguate the ideas between, I mean, really, like, what's the difference between left recursion and, the difference between, between that and enforcing operator precedence. And, I hope this was a little educational for you guys. I know it was fun for us. Thanks a lot. Thanks for a great semester.